Hello students, welcome to Target Global Academy. It's me Shabas. Okay, I know you guys are having your term 1 exam in your school. So we Target Global Academy conducting a term 1 crash course. Clear? So I'm Shabas Ahmed. I am the physics faculty of Target Global Academy. So let's start. We don't have enough time, so let's start. So our first chapter, light reflection and refraction. This chapter is very important because 60% listen guys, 60% of your board exam questions are coming from this chapter. Clear? Okay. So let's start. The chapter starts with reflection of light. Okay, we know what is reflection. Like light is hitting on a mirror and it is retracing back. That is simple reflection. So first we have to discuss about law of reflection. So the first one, you can see this is a mirror, and yeah, light is coming like this. Okay, light is coming and hitting on the mirror and it is reflecting back. Clear? So the incident ray, this is my incident ray, this is my reflected ray, and this is the normal. Clear? So the angle between incident ray and normal is called I, or angle of incidence, and angle between the reflected ray and normal is called angle of reflection. So the law of reflection says that, listen guys, incident ray, normal and this reflected ray all will be in the same plane. Clear? The second one, angle I will be equal to angle R. That is, if this is 30 degree, then this will be 30 degree. Clear? If this is 60 degree, then this will be 60 degree. Clear guys? Clear? So there was a question like this. Okay. Suppose this is a mirror. Suppose this is a plain mirror. And the light is coming like this. This is my incident ray, and light is coming out. This is my reflected ray, and the angle between incident ray and reflected ray is given. It is 60 degree. The question was, what is angle of incidence? That was the question. Clear? What will be the question? So what will be the answer? Angle I. What will be angle I? Listen guys, we know angle of incidence. What is meant by angle of incidence? The angle between normal and incident ray. Clear? But here the total angle is given. That is, this is 60 degree. So what will be angle I? This will be 30. This will be 30. That is, this is 30 degree. Angle I equal to 30 degree. Clear guys? Clear? So law of reflection, it is very important. We have two laws, that is incident ray, normal and reflected ray will be in same plane. Next one, angle I will be equal to angle R. Clear? Okay, moving to the next topic, that is we have two types of mirrors. Okay, in this chapter we have discussed about two types of mirrors, that is concave and convex. So listen guys, concave mirrors and convex mirrors. Okay, for concave mirrors, listen guys, the shading will be outside, or I can draw, this is also a concave mirror. Clear? For convex, shading will be inside, or the reflecting surface will be outside. Clear? So I can draw the convex like this. Clear? And concave mirrors, otherwise they are called converging mirrors. Okay, convex mirrors, otherwise called it is diverging mirrors. Clear guys? Clear? Okay. Now next one, image formation in concave mirrors. This is very important. So first we are going to discuss about the rules. We have 4 rules for image formation in concave mirrors. Okay, for concave mirrors. So in this chapter we will discuss only about concave mirrors. Okay, we are not going to discuss about convex mirrors. Clear guys? Clear? Okay, so for concave mirrors, the rules are, suppose this is my concave mirror, this is the principal axis, pole and focus is here, center is here. First rule is a ray is coming parallel to the principal axis. After reflection, it will pass through the focus. This is the first rule. Clear, guys? A ray parallel to principal axis passing through the focus. The second rule, my pole, focus and center. My second rule just opposite to the first rule. Listen, guys. A ray passing through the focus. A ray is passing through the focus. Just opposite to this one. This one, the first rule was a ray is parallel to the principal axis and passing through the focus. Here the ray is passing through the focus. Then it will be going like parallel to the principal axis. Just opposite to the first one. Is it clear? Is it clear? Okay. So next one, next rule, the third rule, that is. Okay. Third rule, this is very simple. Pole, focus, center. If a ray is passing through the center, what will happen? It will retrace the same path. Okay, it will retrace the same path. Clear? Then the last rule, this we already know, we already studied. That if a ray is obliquely inciding on the pole, what will happen? It will reflect with same angle. We know I, this is R, and we know angle I equal to angle R, that is law of reflection. Clear? Or if this is 30 degree, this will be 30 degree. Clear? So these are the 4 rules. So by using these 4 rules, we are going to draw the image formation in concave mirrors. Okay, we have 6 diagrams for image formation in concave mirrors. So first, we are placing the object behind C or beyond C. Object is beyond C. So I am using the first rule. A ray is coming parallel to the principal axis and passing through the focus. Clear, guys? And second rule, passing through the focus and parallel to principal axis. So here they are meeting. This is our image. Clear? Listen, guys, listen. If the image is left to the mirror, or if the image is in front of the mirror, this is our mirror, right? For a concave, the shading will be here. So this will be the reflecting surface. Or if the image is in front of the mirror, then the image is real. Clear? And if the image is under the principal axis, you can see here, this is the principal axis and the image is under the principal axis, right? So if the image is under the principal axis, then it is inverted. Clear? And you can look at the size. This is our object, this is our image. So what is the specialty? It is small. So we can call it is diminished. Clear? Like that, what will be the property of this image? You can see this is our image, So image is on the left side, so it is real. And you can see it is under the principal axis, so it is inverted. And you can see the size, both are same, right? Both are same. So the image is same size. Clear? So in this case also, image is on the left side, and so it is real, and it is under the principal axis, so it is real. And you can look at the size. The object is this size, but the image is bigger, so it is enlarged. Clear? Okay, I hope this is clear. And if an object, listen guys, if an object is placed on focus, the image will be at infinity. And this one is a special case. That is if the object is in between focus and pole. Here, in this special case, the concave mirrors are producing virtual images because the image is on the right side. Clear? Okay, you can in all other cases the images were real. Okay, images were on the left side, but in this case image is on the right side. Clear? Okay, and one more thing you have to remember, that is convex mirrors also producing virtual images, but only concave mirrors are producing enlarged images, enlarged images, enlarged images. Clear? This is very important. Clear, guys? Only concave mirrors can produce enlarged images. We know concave mirrors also producing virtual images, but it is enlarged. So there was a question like they are given, you are given with like some properties of the image. The properties was the image is virtual, erect, and enlarged. What kind of mirror is this? Your image is virtual, then you will think it is not concave, it is convex, but it is enlarged. We know in a special case, concave mirrors are producing virtual images. But if the image is enlarged, then the answer will be concave. Clear? Concave mirror. Clear? Okay, moving to the next topic. Okay, so the uses of concave mirrors, we know concave mirrors are producing enlarged images. Like we are going to we are like taking a photo of something. So we will zoom, right? We will zoom. So like that, concave mirrors are producing zoomed images. That is why we are using shaving mirrors as concave mirrors. Okay, so shaving mirrors are concave mirrors because we want a bigger image. We want a zoom image. That is why we are using concave mirrors, and also dental mirrors. We want a zoom image. That is why we are using concave mirrors as dental mirrors, and in car headlights. Next one, for convex mirrors, uses of convex mirrors. We know convex mirrors are giving zoom out image. Like when you are using your phone camera, you can see 0.5x wide angle. Okay, so like that, convex mirrors are giving wide angle or wide field of vision. Clear? So here the uses are vehicles rear view mirrors. We want a large field of vision. That is why we are using convex mirrors as rear view mirrors. Then we are using, what is this? This is called traffic mirrors or vigilant mirrors, like that. Okay, here we know this is bulged outside. So it's a convex mirror. Clear? Okay, so next topic, that is refraction of light. Refraction is very simple, that is bending of light when light is traveling from one medium to another medium. Here suppose this is air, this is water, and light is going to travel from air to the water. You can see the light must go like this, but there is a small bending. This bending is called refraction. Clear? And one more thing is the refractive index. So refractive index is denoted by N. Refractive index is denoted by N. Okay, denoted by N. N equal to C by V. Here C is speed of light through vacuum or air, and its value is 3 into 10 raised to 8 meter per second. This you have to by heart. This value you have to by heart. Okay, then V is speed of light through any medium. Okay, the medium will be given in the question. And N is refractive index. This equation is very important. Clear? Okay, moving to the next. Yeah, next one is we have a law. Like we already discussed, a law of reflection. Similarly, we have law of refraction. Laws of refraction. Okay, so the first rule is same, that is incident ray, normal, and refracted ray. Incident ray, normal, and refracted ray, all will be in the same plane. The first rule is same. The second rule, that is Snell's law. Clear? That is sin R equal to a constant. This is Snell's law. That is ratio of angle of incidence to ratio of angle of incidence to that of angle of refraction is a constant. That is Snell's law. Clear? That is Snell's law. So that is the second law of reflection. Okay, the first one is incident ray, normal and the refracted ray will be in the same plane. Second one, Snell's law. Okay, so moving to the next one. Okay, so if a light is traveling from a denser medium to a rarer medium, we know when light is traveling from one medium to another medium, there will be a bending. That is called refraction. Here, the light is traveling from denser medium to rarer medium. That is, denser means the medium having refractive index, higher refractive index. Okay, denser means refractive index is higher. Denser means refractive index higher. Here you can see N1 greater than N2. That is, this one is denser, this one is rarer. Clear? So light is traveling from denser medium to rarer medium. So the bending is away from the normal. Clear? So the light, actually the light must go like this, but it is bending away from the normal. Okay. So similarly, here the light is traveling from rarer medium to a denser medium. Clear? So the bending is towards the normal. Bending is towards the normal. This is we are going to apply in case of a glass slab. Okay, for a glass slab, you can see for a glass slab, yeah, this is my incident ray. This is my incident ray, and the light is coming. Actually, the light must go like this. But we have a refraction. Here it is coming from air. It is coming from air. Okay, coming from air, and this is our glass. Clear? So light is coming from a less denser medium to denser medium, or rarer medium to denser medium. So bending is towards the normal. That is why the bending is towards the normal. Clear? Then again here, now the light is inside the glass. Now the light is inside the glass. Okay. Now light is going to travel from glass to air. That is from a denser medium to rarer medium. Clear? So the light is bending away from the normal. Clear? So this is very simple if you use your logic. Okay. So next case. Yeah. Image formation in lenses. We know we have two kinds of lenses: convex lenses and concave lenses. So for convex lenses, otherwise called converging lenses, and concave lenses, otherwise called diverging lenses. So here we have three rules to draw the image formation in lenses. If a ray is passing through the origin, okay, there will be no refraction. It will go like that. There will be no bending. Okay. Second one, if a ray is going like parallel to principal axis, then there will be a refraction, and that ray will pass through the focus. Clear? This is in case of convex lenses. This is in case of concave lenses. Clear? And next one, if a ray is passing through the focus, will be going like parallel to principal axis. Clear? So we have three rules. It is very simple to draw the ray diagram of lenses. So here in this chapter we are going to discuss only about convex lenses. Okay, we already discussed about concave mirrors, but here we are going to discuss about convex lenses. So here you have 6 diagrams based on the position of object. If the object is at infinity, then the image will be formed at focus. Okay, here also we have a special case. That is, if the object is placed in between F and O. If the object is placed in between focus and origin, then also the image is virtual. Image is virtual. Clear? Listen guys, in case of lenses, listen again. In case of lenses, if the image is formed right side, then the image is real. If the image is on the right side, then the image is real. Okay, so in this case also image is formed on the right side, so it is real. In this case also it is real, but in this case image is formed on the left side, so it is virtual. Okay, so this is a special case in convex lenses. Okay, then uses of convex lenses, and once again convex lenses can produce enlarged images like concave mirrors, exactly same as concave mirrors. So convex lenses also produce enlarged images. They also produce virtual images when the object is placed in between F and O. Clear? So next one, yeah, important equations. Important equations. The first one is, now we are going to move to the problems. Okay, we almost covered the theory parts. Now we are going to the problems. That is, we have some important equation. First one is mirror formula. If it is a mirror, you can use this formula. 1 by F equal to 1 by V plus 1 by U. Here F is focal length, and U is object distance, V is image distance. I hope you already know this one. And second one, lens formula, that is 1 by F equal to 1 by V minus 1 by U. Clear? So next one, magnification. Magnification means height of image by height of object. It don't have any unit. Next one, for mirrors, M equal to minus V by U. Magnification equal to minus V by U. For lenses, it will be plus V by U. And one more thing. If M equal to 1, if the value of magnification equal to 1, then the image will be of image and object will be same size. Clear? If magnification is 1, then it's the object will be, so image will be a same size as of the object. Clear? If M is less than 1, okay, it's 0.1, 0.2, 0.3 like that. If M is less than 1, which means the image is small size or diminished. Or if M is greater than 1, which means it is enlarged. The image is enlarged. Clear? One more thing. If M is negative. Suppose you got M as -1, -2, -1.5 something, which means it is inverted. The image is formed under the principal axis. Clear? If M is positive means it is erect. Clear? Okay. Next equation. Yeah, next one is power. Power is very simple. Power is reciprocal of focal length. That is, a small twist is there, reciprocal of focal length, but the focal length must be in meters. Clear? F must be in meters. Or we can use 100 by F in centimeter. In majority of cases, focal length will be given in centimeters. So you can use P equal to 100 divided by F. And its unit is diopter. Okay, now let's go to some problems. Let's solve some problems. Okay, so here listen guys, read the question. The refractive index of water is given. It is 1.33. It is given in the question, right? And the speed of light in air. What is this? It is C. Right, it is C. We have to find the speed of light in water. So what is the equation relating to speed of water with the refractive index? We know N equal to C by V. This is our equation. Right. Here N is given, that is 1.33, and C is given, it is 3 into 10 raised to 8 meter per second. We have to find V. So I am rearranging the equation. So V will be equal to C by N. Clear? So it will be 3 into 10 raised to 8 divided by 1.33. So what is 3 by 1.33? It is around 2.25. 2.25 into 10 raised to 8. You can write 10 raised to 8 like that, meter per second. 2.25 into 10 raised to 8 meter per second. Clear? This is very simple, right? N equal to C by V, a small equation. Okay? Okay, moving to the next question. Yeah. We wish to obtain an erect image. Listen guys, we wish to obtain an erect image using concave mirror. Okay, concave mirror produce erect image only under one circumstance. What is that? Only under the one special case, if the object is placed in between F and O. Clear? Okay, and focal length is given 15 centimeter. What should be the range of distance of the object from the mirror? Very simple, very simple. Listen guys, this is, suppose this is my concave mirror, this is my principal axis, pole, focus and center. We know here the focal length is given, that is the distance from F to P is given, that is 15 centimeter. Right. Here we have to obtain an image. The image must be erect. Image must be erect. We know concave mirrors are producing erect image only if the object is placed in between F and P. Then what will be the range? From 0 to 15. The range must be 0 to 15 centimeter. Clear? Okay, small trick is there. Next one, we have to draw the ray diagram. That is the special case. Pole, focus and center. Now I am going to place the object in between F and P. Okay, so the first rule, sorry, I am using the fourth rule, that is passing through the pole, retracing with the same angle, law of reflection. And second one, the ray is passing through the center. You know, these rays are coming bigger and bigger, like they are going to become broader and broader, right? So we are assuming that they are meeting on the other side. So the image will be formed here. So this is my image. You can see the image is erect because the image is formed above the principal axis. Okay, and what about the size? Size is enlarged. Okay, image is from the right side, which means it is virtual. Clear? Very simple, right? Okay, moving to the next one. Okay, this is a lengthy question. In torches, searchlights and headlights of vehicles, the bulb is placed. We have four options between the poles and the focus, very near to the focus, between the focus and center, and at the center of the curvature. What do you think, guys? In torches and searchlights. Yeah, why we are using searchlights or why we are using torches? We want to travel the light for a long distance. So think, I am going to place the bulb. Here my object is bulb. So where should I place the bulb in order the light must travel a long distance. We know if the object is at focus, image is formed at infinity. Clear? If the object is at focus, image will be formed at infinity. So we can choose this option very near to the focus of the reflector. Then the light will travel to an infinite distance. Clear? Okay. Next one. Yeah. Which of the following statements is true? Maybe is, maybe are. Okay. So first question, a convex lens has 4 diopter power. Convex. So I forgot to tell you something. So the power of concave lens will be negative, and power of convex will be positive. Okay, I gave you the hint. Now, okay, a convex lens has 4 diopter power. So convex has 4 diopter, means it is positive. Okay, that's correct. And it has a focal length 0.25. Yeah, that's okay, because P equal to 1 by F. Okay, so it's okay, it's correct. So I'm choosing it is correct. Now look at the next one. A convex lens has minus 4 diopter power. So we know power of convex will be positive. So this is wrong. Next one, a concave lens has 4 diopter power. We know the power of concave is negative. So this is also wrong. Look at the fourth one. A concave lens has minus 4 diopter. Very good. We know convex has negative power. So this is correct. But its focal length is 0.25. Its focal length will be minus 0.25. Clear? So this is wrong. So the first one is the answer. Okay? Next question. Yeah, a student wants to project an image of candle flame on a screen 60 centimeter in front of a mirror. Okay, he want to project an image. It is 60 centimeter in front of a mirror. Okay, by keeping the flame at a distance of 15 centimeter from its pole. That is, U is given. That is 15 centimeter. What type of mirrors will be using here? We know what is the difference between virtual and real images. Only real images can be projected on a screen. Okay, so which mirror will be we are using here? We know only concave mirrors can produce real images. So the mirror will be concave mirror. Okay, only the images from concave mirrors can be projected on a screen. Clear? Next one, find the linear magnification. Find the linear magnification. Here we can see U is 15 centimeter and V is also given. That is the distance from the mirror to the screen is given. That is 60 centimeter. 60 centimeter. And one more thing, guys. One more thing. We know for concave and convex. Okay. So for concave, you have to take U as negative, V as negative, and F as negative. For convex, you have to take U as negative, F is positive, and V is positive. Okay, you have to by heart this one. You have to understand this one. That is, for concave, everything is negative. For convex, only U is negative. U is negative in all cases because we are just placing the objects always on the left side. We know every reading that is left to the mirror will be negative or left to a lens will be negative. So U will be always negative and V and F will be negative for concave, and for convex U will be negative, F and V will be positive. Okay, so here we have to find the linear magnification. Linear magnification. I know this is a concave mirror, so U will be negative, V will be negative. Clear? You know, linear magnification means normal magnification. So magnification equal to, for mirrors it is minus V by U. Clear? So it is minus U, V is minus 60 divided by U is minus 15. Okay, so minus and minus I am cancelling. So answer will be 60 by 15. It is 4. So minus, this minus is here. So minus 4. Minus 4 is the answer. Minus 4 is the answer. What is the distance between object and its image? This is the next question. Next question. Listen, guys. So I'm just going to draw. Going to draw the picture. Okay. Pole. And here the object is at 15 centimeter. Here the object is at 15 centimeter. And we know this is a concave mirror, and the image is formed. Will be like inverted, and the image distance is given, that is 60 centimeter. We want to find the distance between object and image. That is, we have to find this distance. So what will be the distance? It will be 60 minus 15, because the total length is 60, the small length is 15, so it will be 45 centimeter. Clear? Okay, we have to draw the ray diagram. That is, we have to draw the ray diagram. That is the ray diagram of concave mirror if the object is placed in between pole, focus and center. If the object is placed in between C and F. How I can choose this one? How I know the object is in between C and F? If I place the object at focus, then what will be the image? Image will be at infinity. So it is not the case. If I place the object at C, then where will the image? Image will be at C. Right? So if I place the object in between C and F, then the image will be here or somewhere. Clear? So I am going to complete the diagram. A ray parallel to principal axis and passing through the focus. Second, I can use any one. So I am using this rule, passing through the focus and like parallel to principal axis. Here my this is somewhat curvy. That is why the image is here. Okay. So if you draw with the correct measurements, if you are using scale and protractor, you will get the image exactly here. Clear? Okay. So next question. Yeah. An object is placed at a distance of 60 centimeter from a convex mirror. Okay, from a convex mirror. So here U is given. U is a part, U is given. The object is placed at 60 centimeter from a convex mirror. That is, U is given, that is 60 centimeter. And where is the magnification? Sorry. If the object is placed at 60 centimeter, the magnification is 1 by 2 or 0.5. From this, we get one thing that we know, U will be negative for both concave and convex. We know the equation of magnification M equal to minus V by U for mirrors. Here we are going to find M into U will be equal to minus V. So I am substituting the value here, M equal to 1 by 2 and U equal to minus 60. Minus 60 equal to minus V. Clear? That is, minus 30 will be equal to minus V, or V will be equal to 30 centimeter. This is the first information. This is the answer of the first one. So, sorry, this is the first information we will get. So, the question is where the object should be placed to get the magnification 1 by 3. Here we are not going to change V. We are going to change U. Clear? So we are going to change U. Now in the second case magnification is 1 by 3 and V is 30 centimeter. Now we are going to change U, object distance. So we can find M equal to minus V by U or U equal to minus V by M. That is minus V, minus 30 divided by, what is M here? M equal to 1 by 3. So answer will be, this 3 will come up. So answer will be minus 90 centimeter. U will be equal to minus 90 centimeter. That is 90 centimeter in front of the concave mirror. Clear? Next question. A small electric lamp is placed at the focus of a convex lens. Okay. Draw the ray diagram. So this is the convex lens, this is the convex lens, and this is the principal axis. This is origin. This is F1 to F1 and F2 to F2. Now the object is placed at F1. The object is placed at F1. Okay, without drawing, we can say the image will be at infinity, right? So I'm going to complete this diagram. Here a parallel to principal axis and it is passing through the focus. Second one, a ray is passing through the origin. You can see these two lines are parallel, so they are not going to meet anywhere. So no image will be formed. So we are assuming that they are meeting at infinity. Clear? We are assuming they are going to meet at infinity. So this is a special case. This is a special case. If the image will be formed at infinity when the object is placed at focus. Okay, so that's all, guys. I hope this chapter is very simple for you. And here we discussed some complicated problems only. Okay, so small problems are like simple problems are there, but we are not using that. And one more equation is the R equal to 2F. That is, focal length will be double of the radius. Clear? So I am winding up, guys. My name is Shahbaz Ahmed and I am the physics faculty of Target Global Academy. Okay, now our chemistry sir, Shamir sir will join you. Okay, guys. Bye.
Hello guys, welcome back to this Target Global Academy. Term 1 crash course is the chemistry class. We are starting after the successful energetic physics class. We are going to start our chemistry class. You know, we have 2 chapters to cover. First chapter is chemical reactions and equations, and the second chapter is acids, bases and salt. We know up to pH. Up to pH we have the class. Hi all, welcome to the class all. Okay. So we are going to discuss about 12 or 13 questions from first chapter, as well as 8 or 9 questions from second chapter. I can ensure that you will get maximum score about 75% score, and I am the chemistry faculty from Target Global Academy. My name is Shamir. Yes. Okay, we are starting. Let's go. Okay, hi. So we are dealing with the first chapter, chemical reactions and equations. If you are dealing about chemical reactions and equation, before going to the question, I can say you some important points in chemical reactions and equations. We have two parts. You can divide the chapter to two parts. One is balancing of a chemical reaction, or chemical equation, and the types of reaction. You cannot predict the question of balancing. So you should have a clear idea, a clear-cut idea about balancing. Now I am going to concentrate on types of reaction. You know the types of reaction, 5 types are there. Combination reaction, decomposition reaction, displacement reaction, double displacement reaction, and oxidation reduction reaction. You can say that you should study one example from each of these reactions. Okay. Anyway, let's go to the types of reaction portion. Then only we can come back to balancing of chemical reaction. Okay. Okay. So move to the first question. 2 reactions are given. Okay, that's fine. Reaction P and reaction Q. The reaction P is CaO plus SO2 gives CaSO3, and the reaction Q is ZnCO3 gives ZnO plus CO2. Okay, which reaction is an example of combination? Okay, 1 minute. Okay, which reaction is an example of combination and which reaction is an example of decomposition? What is the answer? What about the answer? Here the answer is, you can see in the reaction P, you can see 2 reactants and combine to form a single product. That is the point. Okay, but in the reaction Q, what happened? Only one reactant is there. After the reaction, you can see several products, maybe 2 products. So in the first reaction, you can see two things combined to form a single thing. So first one is combination. Okay, both the reactions are combination. Wait, before going for our option, just we have an idea. We should have an idea. Okay, come to the second. Okay, here only one thing is there. Only one reactant is there, and after the reaction, you can see 2 products. So the first one is combination reaction. Why it is combination? Because 2 reactants combine to form a single product. In the second case, a single reactant. My word is important, not simple, but single reactant react to form multiple products. So that is known as decomposition reaction. Decomposition reaction. So which is the correct option? Both reactions are combination. No, both are not combination. How it become combination? It's not combination. Okay, then both reactions are decomposition. No, reaction P is not decomposition. Never. So P is an example of combination and Q is an example of decomposition. So C is your right answer. Yeah, correct. Mr. Unknown answered that C is the right answer. Yes. I don't know, still unknown, but he is good. He or she is good. He answered. Good. Okay. Okay, let's move to the second question. Okay, I think his question is clear. Yeah, correct. Bob also answered. Good. Okay, sorry. Okay, the unknown is Sohan. Okay, fine. So the second question, give one example of a combination reaction which is also exothermic. So your reaction must be combination. Combination means what? A plus B gives AB. This is combination reaction. A is something, B is something. You are combining A and B and forming, there is a bonding between A and B. That is combination. And it should be exothermic, which is the simple reaction. Okay, you can think about oxidation reaction. Combination reactions are normally exothermic. For example, C plus O2, CO2. This is a combination reaction, right? Carbon react with oxygen, and after combining, you will get CO2. Okay, so this is exothermic too. It can release heat. It can release heat energy. Why? After burning a paper, you feel coldness? No. You feel hotness. So that is the content. C plus O2 gives CO2. Any oxidation reaction you can write. Okay, but you cannot write that methane. Have you remember the oxidation reaction of methane? CH4 plus 2O2 gives CO2 plus 2H2. You cannot write that because that is an exothermic reaction. That's fine, but it's not combination. Okay, that is important. Come to the next question. Electrolysis of water is a decomposition reaction. We know that. Electrolysis of water, we know. The molar ratio of hydrogen and oxygen gas is liberated during electrolysis. So after the electrolysis, what is the molar ratio of hydrogen and oxygen? So let's have a look on the reaction. Okay, actually what happened? H2O reacts. H2O decomposition, electrolysis. Yeah. Answer is there. B is the right answer. Let's check. Okay. H2 plus O2. After balancing, you will get 2H2O gives 2H2 plus O2. Molar ratio means what? Molar ratio means this coefficient. Here you can see only 1. Here it is 2. Yeah, 2:1 is the right answer. Molar ratio. Friends, if they are asking about the ratio of mass, what's your answer? Here, if you can see 4 hydrogen and 32 oxygen, 4:32. That is 2:16. Yeah, correct. So many people are answering. Very nice, very nice. Good. Okay, go to the next question. Okay, here molar ratio. Molar ratio means you just take the coefficient. Here 2, here 1. 2:1. Hydrogen is to oxygen is 2:1. Okay. Next one. Next question. Which among the following statement is or are true? Exposure of, so many people answer in the last question. I'm happy. Okay. Exposure of silver chloride to sunlight for a long duration turns white, turns gray due to. So if you are exposing, okay, in presence of sunlight, our silver chloride become silver. It color changes to white, from white to gray. So they are asking about the reason. The formation of silver by decomposition of silver chloride. Okay, you can see, you can write the equation. AgCl is there. You can take an in presence of sunlight, it decomposes like this. Okay, like this it will decompose. So you can see the formation of silver by decomposition of silver chloride. So that's one of the correct statements. Okay, so this is correct. Sublimation of silver chloride, friends, it is not sublimation. Sublimation of silver chloride is wrong. Why? What is sublimation? What is sublimation? Sublimation is the conversion of solid substance to gas. Actually, you can see AgCl is solid, no problem. But here silver is also solid. Here the chlorine is only the gaseous substance. Okay, here you can see silver chloride. Silver chloride is a solid substance, silver is solid. So it's not sublimation. Sublimation is not happening there. Decomposition of chlorine gas from silver chloride, that's already wrong. That is, you can read that sentence again. Decomposition of chlorine gas. No. Decomposition of silver chloride and form chlorine gas. Oxidation of silver chloride. Oxidation of silver chloride. Silver chloride is oxidized? No. Okay. No. Oxidation of silver chloride you cannot say. Oxidation means what? Addition of oxygen. Any oxygen is there? No. Oxidation of silver chloride is wrong. So one only. A is the right answer. Okay, so you should be very careful while answering this kind of MCQ questions. MCQ questions are not easy. Okay, easy, but some concepts is there. Okay, so please be very aware of that. Okay, move to the next question. Fifth one. Which of the following reaction is an endothermic reaction? What do you mean by endothermic? What is the difference between exothermic reaction and endothermic reaction? Exothermic reaction is the reaction in which heat is released or liberated. Endothermic reaction means what? The heat is absorbed during a reaction. Okay, burning of coal. Coal means carbon. Okay, coal means carbon. So burning of coal is not the answer, because after burning coal, after burning carbon, you will get heat. It's exothermic. Next, decomposition of vegetable matter into compost. You know, this one is also exothermic. I think you studied in that portion. Okay, if you have some some biodegradable substance and its decomposition, it's exothermic. Process of respiration. After respiration, you will get some energy, heat. That is exothermic. Yeah, Mr. Unknown. B is the correct answer. Decomposition of calcium carbonate. You know, calcium carbonate absorb heat. It's a thermal decomposition. That is the decomposition using heat. Yeah, Khadija Ashmin and non answered. Yeah, CaO plus CO2, thermal decomposition. It is a decomposition reaction and this is endothermic. Yeah, Yusuf Abdul Latif answered. Good. Okay, come to the next question. Come on. Next question. Yeah, zeros and one answered. Okay. When potassium iodide solution is added to a solution of lead nitrate in a test tube, the precipitation is formed. You can ensure the two questions, one question is the same. Okay. I mean, this question is very important. They may ask this question. In our notebook, in our printed note, it's very clear that this was very important. Okay. So name the compound precipitated. You are taking potassium iodide and adding lead nitrate to it. What happened? What happened? This is double displacement reaction. Double displacement reaction. Exchange of ions occurs. What is the precipitate form? Precipitate form is lead iodide. So you should name the compound. Okay, not the chemical formula. Yeah, Wawa answered first. Okay, Wawa. Okay, previous question. Yeah, lead iodide. Yeah, Mr. Unknown. Lead iodide. Lead iodide. Yeah. And what is its color? What is its color? Either in violet, green, pink. What is the color? What is the color? Lead iodide. Color is yellow. Yellow. Yeah, correct. So many people answered. Mr. Unknown and Khadija Ashbin, Yusuf Abdul Latif. Yeah, Fatima answered. Okay, good. Write the balanced chemical equation. You should study this balanced chemical equation. This one is lead nitrate PbNO3 twice plus potassium iodide Ki 2Ki gives PbI2. This is lead iodide plus KNO3. There are 2KNO3 is there. Clear? This is the balanced equation. You can make sure that you should study this equation. This is very important. Okay. So list two types of reaction in which the reaction can be placed. So you know, one is double displacement. So this lead iodide is precipitate, right? It is a solid residue. It is a yellow colored residue. It's a kind of precipitate. So this reaction also known as precipitation reaction. Precipitation reaction. So you can write it as double displacement is you can include this reaction with double displacement as well as precipitation reaction. Both are correct. Okay. Is it clear? Is it clear? Okay. Then let's go to the next question. Okay. Seventh question. 2 gram of ferrous sulfate crystals are heated in a dry boiling tube. Okay, list any two observation. Okay, list any two observation. What is the observation? Ferrous sulfate means what? Ferrous sulfate means FeSO4. What is the color of ferrous sulfate? Ferrous sulfate, a hydrated ferrous sulfate. What is the color? Color of ferrous sulfate is green. Green. When you heated this ferrous sulfate, its water will lose and its color will change. Its color changes to colorless or white. So first observation is the color change. Yes, Mr. Unknown. Color change, green to white. Okay, that is the first point. Second point is you can see some evolution of gas. Oh, correct. Yeah, some evolution of gas. Some gas will be evolved. SO2, sulfur dioxide, which is very toxic gas. Okay, it will evolve. Name the type of chemical reaction taking place. Which is the type of chemical reaction? Using heat. Only a single reactant we have taken. That is our ferrous sulfate. We have heated. Yes. Yeah, SO2, SO3 is forming. Okay, fine. So, which is the reaction? Decomposition reaction. Thermal decomposition reaction. Correct? Yeah. Thermal decomposition reaction. Come to the next one. Write the balanced chemical equation for the reaction. We have to write, not decompression, but decomposition. Okay. The balanced chemical equation is FeSO4. We have taken FeSO4 and we have heating. Nothing is there. Only one reactant. After the reaction, you will get Fe2O3. Fe2O3 plus SO2 plus SO4. You can see 2 sulfur is there. Only one sulfur. Put a 2 here. Fe2. Everything is balanced. Okay. So this is thermal decomposition. Similar reaction is there in your textbook. That is a decomposition of lead nitrate. Formation of brown fumes. Okay, brown gas. Nitrogen dioxide. Yeah. 4NO2 is forming. Please refer that reaction too. Parallelly, you can refer that reaction. PbNO3 twice heating, you will get PbO. Okay, plus 4NO2 plus O2. Please refer. Now itself you should refer. Okay, go to the 8th question. What happens when copper rod dipped in iron sulfate solution? This is what reaction? This is displacement reaction. You have putting some copper. Okay, you have taken some copper and it is dipped in which solution? FeSO4, right? Ferrous sulfate solution, iron sulfate solution. What happened? Is there any reaction? Is there any reaction will occur? No, no reaction. No reaction is the correct answer. Why? Because this copper, very unreactive, means very less reactive metal is copper. Okay, this copper is very less reactive, and iron is more reactive than copper. Okay, some imitating gold is less reactive. You know that, and iron is more reactive compared to copper. Yeah, correct. Yusuf Abdul Latif and Mr. Unknown, yeah, correct. No reaction is the correct answer. Okay, good. Next one, 9th one. A brown substance X on heating in air forms a substance Y. So you have a substance X. You are simply heating in presence of air plus O2, you will get Y. The X is brown and the Y is black. Okay, anyway, color is not given. Okay, fine. When hydrogen gas is passed over Y, it again changes to X. Okay, this reaction is not directly not there in your NCERT textbook. But after the oxidation reduction, one page you can see at the title of oxidation reduction. At the end of that page, you can see this reaction. Okay, so this reaction, name the substance X and Y. Anyway, the substance is Cu and CuO, copper and copper oxide. Please refer your textbook. Your NCERT textbook is your guide. Don't use another guide. Use your NCERT textbook itself is your guide. Okay. So copper on reacting with oxygen, you will get copper oxide. Okay. Name the type of reaction occurring. So when you keep copper oxide plus hydrogen, what happen? You will get Cu plus H2O. So this is the reaction. This is the complete reaction. The first reaction is oxidation reaction. Correct. Addition of oxygen. Second reaction is redox reaction. Oxidation is happening, right? H2, oxygen is added. In the case of CuO, oxygen is removed. So it is redox. Okay. So this is quite kind of variety question, not a repeated question. So you should refer that reaction. CuO plus H2 gives Cu plus H2O. So clear? Okay. Next one, a shining metal M. Don't think about the shining metals like gold, silver. Don't think about. Right away the question. Burning gives a dazzling white flame and changes to a white powder N. Students, friends, have you remember your first experiment? Experiment 1.1. Correct. Perfect. Mr. Unknown, magnesium is the metal. Your first experiment 1.1 at the end of your first page, your chapter is starting, for example, chapter is starting here. At the end of that page, you can see that experiment. So magnesium is the metal, M is magnesium. Okay, after burning it turns to N. N means what? Magnesium turns to magnesium oxide on reacting with O2. Correct? Yes, correct. Okay. Represent the above reaction in the form of balanced chemical equation, already balanced. We written. Does M undergo oxidation or reduction? M undergo oxidation or reduction? Either oxidation. You can refer this chemical equation and you can say whether oxidation or reduction. Perfect. Oxidation, because addition of oxygen is happening there, right? Addition of oxygen. So this is oxidation. Clear? Okay. Yeah, Zara, correct. Oxidation. Next one. Some reaction is given. I can enlarge that reaction here again. Zinc oxide plus carbon gives zinc plus carbon monoxide. So what happened here? Here both sides in this kind of reaction they may give. In this time, don't be panic. You can draw some line by connecting two zinc to carbon. What is the change? Here you can see, here zinc, oxygen is there with zinc, but here it is kind of only zinc is there. Okay, it is alone. So you can see this is reduction, correct? This is reduction. This one you can see carbon is only here. Addition of oxygen happened, then carbon monoxide is formed. That is oxidation. Okay, then go to the your option. Carbon is reduced and zinc is oxidized. Is it correct? No, this is not correct. Because carbon is oxidized, oxygen is added. Carbon is oxidized and zinc is reduced. Correct, right? Carbon is oxidized. Yes, correct. Zinc is reduced. Yes, this is correct. Zinc is oxidized. No. Zinc is no. Students, to no, Mr. Unknown, D is not the correct answer. B is the correct answer. Okay, anyway, here you can say that to state oxidation and reduction, don't look to products. Only you only refer the reactants. What happened to zinc oxide? What happened to carbon? Carbon attained one more oxygen, then it is oxidized. Zinc oxide removed its oxygen, then it reduced. Is it clear? Is it clear? Okay. So the next question, like our double displacement, sodium sulfate react with aqueous solution of barium chloride. State the physical condition of reactant in which the reaction between them will not take place. So read the question very clearly. This one is very important question. Double displacement. So we have taken sodium. Okay, write the balanced equation. Name the two types of reaction which this reaction can be placed. So this is double displacement reaction as well as precipitation reaction. So I can write the balanced equation. You have taken sodium sulfate, added barium chloride. So take the first element of the second component, second group of the first component. You will get BaSO4 plus 2NaCl. And one more thing is there. State the physical condition of reactants in which the reaction between them will not take place. So these two groups are in aqueous solution. Means actually they are salts. Means like our common salt, they are crystals. We should dissolve it in water. Aqueous means water containing. Otherwise, there is no reaction. Okay? Okay, is it correct? That means that sodium sulfate and barium chloride should dissolve in water. Otherwise, no reaction. If you are mixing some salt of sodium sulfate, if you are mixing some salt of barium chloride, there is no use. There will not occur this reaction. You can write this point somewhere. Double displacement reaction will occur only in aqueous solution. Strictly in aqueous solution. Otherwise, this reaction will not occur. Why? Some teacher, maybe in your next exam, they will ask why it will occur only in aqueous reaction. Because in double displacement reaction, there occurs exchange of ions. Okay, exchange of ions. Ions is only forming in aqueous solution. If it is in solid state, you will not get the product. Yeah, that's the correct answer. Ions should be there. Ions is only there in aqueous solution. I think it's clear. Okay. Yeah, exchange. Correct. So next one is case study. Case study means some paragraph will be given and you have to answer the questions following that. Okay, go for that. Ajay, okay, anyway, Ajay wanted his house to be whitewashed. He bought 10 kilogram of quicklime. Okay, from the markets. Before mixing all 10 kilogram, he took one beaker and took small quantity of quicklime in a beaker. Then he added some water. Okay, anyway, I'm going to the question. Okay, I'm going to the question. What is formed when water is added to quicklime? This is a famous reaction where in textbook where you can see this reaction at the starting of combination reaction. Some experiment is there. What happened? Calcium oxide reacting with the water, forming calcium hydroxide, CaOH twice. Clear? the nature of the product. So students, one question is there. Actually, this question is from your second chapter. Anything. So write it somewhere. Any material, I mean any chemical with OH is basic. Okay, not for alcohol. Alcohol also contains OH, but that is different. NaOH, COH twice, KOH, like OH containing chemical is basic in nature. Okay, basic in nature. Most of the people answered it is neutral in some exams. So it is not neutral, it is basic in nature. Pakka, calcium hydroxide is pakka basic in nature. Okay, next one. Okay, we are moving to the end of our first chapter. The chemical reaction between the quicklime and water. Okay, you can see some hotness, that means change in temperature. Okay, and there is no change in color. Formation of slaked lime precipitate. Slaked lime precipitate means what? Slaked lime precipitate means CaOH twice. CaOH twice. Okay. So the correct answer is B and C. Formation of which of the following substance is responsible for the shining finish of the walls after whitewash? So it is CaCO3. I will explain with you. So we know during whitewash we use CaO, right? Due to the presence of carbon dioxide in our atmosphere, it will react with CO2 and forming CaCO3. Okay, in our atmosphere carbon dioxide is there, so it is forming. Okay, it is the reason for the shining finish. Okay, so this is about our types of reaction, and you have to study. You have to study at least one example from each type of reaction. They can ask any question. Okay, no problem. Everything is there. We discussed most of the questions. Most of the important 13 questions we covered. Most of the important questions. And what is remaining is that balancing. Balancing is very important, but it is very easy. Okay, but it is very easy. From the reactant side, product side, you can just number. You can just give number to reactant side and product side, how many atoms are there, and you can check. Okay, I will give you some examples. For example, I am going to balance here. Okay, I am going to balance here aluminium reacting with HCl, forming AlCl3 plus H2. This is a reaction. This is the only reaction that I am going to balance. Okay, here you know aluminium is there, hydrogen is there, chlorine is there. Okay, here also aluminium is there, hydrogen is there, chlorine is there. How many aluminium? Only one aluminium. Here also only one. Here you can see one hydrogen, two hydrogen. Here you can see chlorine 1, 3. Okay, what is the problem here? Here, this chlorine and this is one chlorine, this is 3 chlorine. If you are taking, okay, if you are taking 3, it may be difficult. If you are multiplying with 3, what happened? You cannot write it as 3 because 2. Because here what you have to do is you should select your starting point. Okay, yeah, it's important. So you should select a starting point. Here you can see, here you select an odd number. In these numbers, please select an odd number other than 1. Here the 3 is the only odd number other than 1. Make that 3 6. Make that 3 to an even number. How? By multiplying by 2. So keep it 2 here. Then your aluminium become 2. Chlorine 6. Hydrogen now it is 6 to aluminium. Okay, so what is your Fatima, what you are asking? Balancing is important, but we cannot say, but we cannot predict the reaction. You should balance all the reaction in your NCERT textbook, and at the end of your chapter some questions are there. So do the questions pakka, then you will be master in balancing. It's very easy, but it's important. Okay, you may get questions of balancing also. Okay, I think it's clear. Then let's move to the second chapter, acids, bases and salt. I think most of the schools this chapter is not there for completely not there for term 1 examination, but it is there up to dilution or pH. Okay, let's move to some questions. Here, may a metal carbonate react with a solution X, okay, which forms a salt. Okay, water and a gas. What is X and Y? So here a metal carbonate. I am taking a metal carbonate. It's my choice to take a metal carbonate. That I didn't mention any metal carbonate. So I am taking CaCO3 and reacting with a solution X. Okay, some X is there, and you will get a salt, water, and a gas Y. So students, if you are taking a metal carbonate on reacting with an acid, there occurs the evolution of carbon dioxide. So Y is carbon dioxide. So you can see here carbon dioxide is there and here carbon dioxide is there. So the reaction between metal carbonate and acid yield a salt and carbon dioxide. So acid is hydrochloric acid only. So C is the correct answer. So for metal carbonate react with acid, it will form a salt and water and carbon dioxide gas, because carbonate contains CO3, it will allow the evolution of CO2 from there. Is it clear? Second question. 4 students were asked to test the pH of the 4 samples. So water, ethanoic acid, HCl, NaOH. So you know the pH of water is 7. Okay. pH of ethanoic acid should be less than 7. For acids, pH should be less than 7. You know, for bases, pH should be greater than 7. You know, here which is strong acid, ethanoic acid or HCl? HCl. Sir, how do we know? Yeah, so Mr. Anon asking that how we know that the Y is carbon dioxide. There it is crystal clear that they have taken a metal carbonate on heating or reacting with acid with yield carbon dioxide. That is the idea. That is the only idea we have. So metal carbonate we have on heating metal carbonate or reacting an acid with metal carbonate, you will get carbon dioxide. Yeah, that is the only idea. Clear? Okay, so comparing ethanoic acid and HCl, HCl is a strong acid. Stronger the acid, then pH will be less. Okay, so pH will be less, HCl have 1 and ethanoic acid have 3. This one is the correct answer, D is the correct answer. Okay, means student D is did it correctly, because water should have 7, acid should have less than 7, HCl is very strong, so very less value. Okay, it is 1 and ethanoic acid 3, NaOH having greater than 7, that is 13. Is it clear? So moving to the next question. Dry ammonia gas has no action on litmus paper, but a solution of ammonia turns red litmus blue. So what is the reason? So in litmus paper, the things should be wet, aqueous solution needed. Why aqueous solution? Same as a double displacement, ions needed. In litmus paper we needed ions. So dry litmus paper or dry thing we cannot take it. Okay, so that is the reason. Then two solutions A and B have pH 3 and 10.5. Which of these will turn red litmus, blue litmus red and phenolphthalein from colorless to pink? Blue to red. Blue to red conversion means what? It is acid. Blue to red conversion. Litmus paper. What about phenolphthalein? Colorless to pink. That means base. Acid have less than pH less than 7. So it is A. A will change blue to red. Okay. What about colorless to pink? It is base 10.5. That is B, greater than 7. Okay. Yeah, this question. 15 ml of water and 10 ml of concentrated sulfuric acid to be mixed in a beaker. State the method that should be followed with the reason. That means we should take water first, then we should add drop wise acid to it. Okay, then you will get the then you can mix the water and acid. Then what is the process called? This process is called dilution. Dilution. Okay, so not dissolution but dilution, both are different. Next one. Which of the following is correct about an aqueous solution of acid and bases? Higher the pH, stronger the acid. That is wrong. If the pH is very higher, then it is basic. Okay, higher the pH, weaker the acid. That is correct. That is correct. Okay. Lower the pH, stronger the base. It's wrong. Lower the pH, weaker the base. Okay. Which one? Mr. Unknown, which one can you explain again? Which question I have to explain? Either dilution or something. Can you see? Can you please tell me the question number 7, 6? Is it 5? For fifth question. Okay. You need explanation on fifth question. So in fifth question, they are asking that you have 15 ml of water and concentrated sulfuric acid, right? Okay. So you have to mix. So you should take acid. You should add acid to water. You have some water with you and you should add acid to water. Otherwise, it will make explosion. Okay. If you are going to add water to acid, it is an exothermic reaction and cause explosion and cause severe burnings. Okay. So that is known as dilution. Is it clear now? Okay. Okay, fine. What is an alkali? What do you mean by alkali? Give an example. HCl, HNO3. Okay. What is an alkali? What is an alkali? Alkali is a base dissolved in water. Okay, all bases will not dissolve in water. That's the case. Sodium hydroxide, NaOH, is an alkali. But aluminium hydroxide is not an alkali. It is a base, but it will not dissolve in water. That's not an alkali. Okay, why do HCl, HNO3, etc. show acidic characters in aqueous solution, while solutions of compounds like alcohol and glucose do not show acidic character? Because HCl and HNO3 can donate H plus ions in water. That is the reason for the acidic character. Is it clear? But in the case of our alcohol or glucose cannot donate H plus ion. That is the reason. Write somewhere. Okay. Name the acid present in andestic and give its chemical formula. That is formic acid or methanoic acid. HCOH. Give the common method to get relief. We can put some baking soda or something. Yeah, baking soda is, you can make a paste of baking soda, then you can apply where andestic happen. Okay. So this is a common question. Yeah, one more question. Identify the compound. Identify the compound X on the basis of the reaction given below. Say, before going to this question, yeah, compound X. Make marker. Yeah, compound X react with zinc, forming A and H2. Compound X react with HCl, forming B and H2O. Compound X react with the acetic acid, forming C and H2O. So this question is little bit kind of twisting, but easy. Okay, say I have a compound reacting with the zinc, forming A and H2 gas. Okay, say I have another same compound X reacting with HCl, forming B and H2O. That means when an acid reacts with a base, there occurs the formation of salt and water. So this one is acid, you know, HCl. So this one will be base. Okay, this one will be base. X is a base. Either NaOH or KOH, anything. So in textbook it is NaOH because you studied, you studied NaOH plus zinc. Zinc react with the base forming sodium zincate. So the A is sodium zincate. So leave that So go through your reaction part. Okay, the second chapter at the starting, something is there about indicators, visual indicators, olfactory indicators, indicators having different smell, acidic and basic media are known as olfactory indicators. Something is there, and some reaction is there, acid plus base. Okay, I can conclude with that reaction. Any acid react with base forming salt and water. Okay, so like that, any metal excluding copper and gold, there is very less reactive. Metal with the acid or base, you can react with the acid or base, you will get salt plus hydrogen gas, not H2O but H2, hydrogen gas. Okay, so I am winding up. And that part, dilution, the part of dilution is also important. So this is of all your second chapter, acids, bases and salt. Our time is very limited, you know, but we covered almost the important questions in first chapter. First chapter means our chemical reactions and equation, and our second chapter, acid, bases and salt. Your biology teacher is waiting for you for your biology class. I'm winding up. This is the chemistry faculty of Target Global Academy. Okay, so thank you.
Hi everyone, how are you? Okay, Shamir sir is beautifully completed his chemistry section. Now we are moving into the beautiful area that is biology. Okay, we are discussing about life process. It is our first chapter, that is life process. In this chapter, we are discussing about nutrition, respiration, transportation and excretion. In nutrition, we are discussing about autotrophic nutrition, heterotrophic nutrition. In respiration, we will discuss about cellular respiration, what is the respiratory system of humans, and what are the process and how the plants are respired. Then in transportation, we are discussing about human circulatory system and transportation in plants. And finally, the excretion, we are discussing mainly about human excretory system and what are the excretory products formed in plants. In this section, we are mainly focusing on top 10 questions from this chapter. The first question was, list two differences between holozoic nutrition and saprophytic nutrition with two examples. Okay, what do you mean by holozoic nutrition and saprophytic nutrition? We will discuss about heterotrophic nutrition. What do you mean by heterotrophic nutrition? The animals, especially humans or amoeba, which are depending directly or indirectly the autotrophic organism. Autotrophic organism, the best example for the autotrophic organism was plants. Okay, we can divide the heterotrophic nutrition into holozoic nutrition, saprophytic nutrition and parasitic nutrition. In holozoic nutrition, okay, what do you mean by holozoic nutrition? The nutrition that we are seeing in humans. Okay, our digestive system are part of the holozoic nutrition. Then saprophytic nutrition, the saprophytic nutrition in which the dead and the decaying materials, okay, that are the nutrients. Okay, in holozoic nutrition, wait a minute. Okay, holozoic nutrition, okay, complex carbohydrate molecules like starch are converted into simple molecule like glucose. Starch are converting into glucose. What about proteins? Proteins are converting into amino acids. The entire process that is take place inside our body. Okay, the entire digestion that is take place inside the body And in holozoic nutrition, it is a multiple steps are present. Okay, there is ejection, digestion, absorption, assimilation, etc. These are the steps of holozoic nutrition. What about saprophytic nutrition? In saprophytic nutrition, dead inorganic material, the dead materials has been used for saprophytic organism for their digestion. They will digested into inorganic compounds. Examples for saprophytic nutrition are fungus and some bacteria. They are also decomposes. Okay, the difference is in holozoic nutrition, the digestion takes place inside the body. In the saprophytic nutrition, the digestion takes place outside their body. They are secreting enzymes outside. Okay, that's why their nutritions are take place outside the body. These are the main difference. And in saprophytic nutrition, it's a single step process. But in holozoic nutrition, there are multiple steps used for the digestion of materials like complex carbohydrates. The examples for holozoic nutrition, animals like human beings, amoebas are the examples of holozoic nutrition. For saprophytic nutrition, that is fungus there and bacteria are examples of saprophytic nutrition. Then we will move into the next question, that is enumerate the events that actually happen during the process of photosynthesis. Okay, in photosynthesis, the light energy is used for synthesizing foods. It is take place in plants where this take place in the leaf. The first event of photosynthesis is absorption of light energy by chlorophyll molecule. What is it? Absorption of light energy. Absorption of light energy by chlorophyll. Where we can see the chlorophyll. Chlorophylls are present inside the leaf. In the mesophyll cell, there is a chloroplast there. Inside the chloroplast, we can see the chlorophyll. Chlorophyll is a green pigment that is very important for photosynthesis. And the second one is conversion of light energy into chemical energy. The light energy from the sun is converting into chemical energy. Here, there is also another process also take place in this area, that is the splitting of water molecule. The water molecules become split and form two H2 plus O2. That is 2H2 plus O2. Okay, here this oxygen that was we are respiring. Okay, get the idea. And the third process, the third event is the reduction of CO2. The CO2 undergo reduction. CO2 undergo reduction to form carbohydrates. Okay. The CO2 undergo reduction to form the carbohydrate. What is the formula? That is C6. Sorry, CO. Okay, clear this. Okay, that is CO2, that is 6CO2 plus 12H2O in presence of light and chlorophyll. What will be from C6H12O6, that is glucose, plus 6 oxygen molecules are formed and 6 molecules of water is also formed. Here, the 6 carbon that is present in the glucose are formed from the carbon of CO2. Okay, the 6 carbons that are present in the glucose are formed from the carbon of CO2. Okay, these are the 3 events that take place during photosynthesis. Okay, okay, is it clear? Fatima, is it clear? Okay, then we can move into the next question. Why is nutrition is necessary for human body? What's the importance of nutrition? The nutrition is very important because nutrition, okay, nutrition is performing the daily activities of our body. Okay, we want energy for performing the daily activities and also maintaining our body functions. That's why nutrition is very important. That's why the nutrition is very important. Then the second question, what causes the movement of food inside the alimentary canal? Inside the alimentary canal, food was moved like this. It's a wavy movement inside the alimentary canal. If you are considering an alimentary canal, the food is moving like this. Okay, there is a wavy movements here. The wavy movements are called peristalsis. What is called? Peristalsis. Okay, that is peristalsis. What's the definition for peristalsis? It is the rhythmic contraction and relaxation of the walls of alimentary canal to push the food forward. That is called peristalsis. What is it? The rhythmic contraction and relaxation of walls of alimentary canal to push the food forward. That is called peristaltic movements. Okay, it is seen in the alimentary canal. Then the third question, why is small intestine in herbivores longer than in carnivores? In herbivores, what do you mean by herbivores? Herbivores, they are eating plants. When you study the plant cell was covered by a cell wall. The cell wall that is made up of cellulose and hemicellulose. The cell wall is made up of cellulose and hemicellulose. The digesting enzymes for cellulose and hemicellulose are absent in. The digesting enzyme for cellulose and hemicellulose are absent in alimentary canals of animals. Okay, that's why the herbivores, their alimentary canal is long to digest the cellulose. What about carnivores? Carnivores are meat eaters. Okay, in animal cell there is no cell wall there. That's why they do not want the intestine or the small intestine long. That's why in carnivores the small intestine is very short. Then the fourth question, what will happen if mucus is not secreted by gastric gland? When we study human digestive system, we will discuss about alimentary canal and digestive glands. Okay, in the gastric gland, okay, secretion of gastric glands are called a gastric secretion. What is called? Gastric secretion. The gastric secretion that involve HCl. What do you mean by HCl? That is hydrochloric acid. And the second one is mucus. And the third one is, what is the third one? That is pepsin. Okay, that is HCl, mucus and pepsin there. Then here we are discussing about mucus. Mucus that is protect the inner lining of stomach. Mucus that protect the inner lining of stomach from the acidic action of HCl. Mucus that protect the inner lining of stomach from the acidic action of HCl. HCl, the pH is very high. That is, the acidicity is very high, the pH is very low, the acidicity is very high. That's why the entire walls have become protected by mucus. Is it clear? Is it clear? Is it clear? Then we can move into the next question. That is the fourth question. If salivary amylase is lacking in saliva. Okay, look the question. If the salivary amylase is lacking saliva, which of the event in the mouth will be affected? If in the mouth the salivary gland is there, The salivary gland secretes saliva. The saliva containing the digestive enzyme salivary amylase. What is called? Salivary amylase. If the salivary amylase is absent, what will happen? What is the function? First, we can discuss about what is the function of salivary amylase. Salivary amylase digests starch into simple sugars. Okay, the salivary amylase digests starch into simple sugars. Then the answer is protein breaking down into amino acids. It is not the function of salivary amylase. Starch break down into sugars. This is the function of salivary amylase. If the salivary amylase is not present or it is lacked in the saliva, then the starch is not broken down into sugar. This process is affected. The second option is correct. What about fat? Fat breaking down into fatty acids and glycerol. This process is take place in small intestine. Which enzyme is helping? That is lipase. The pancreatic lipase enzyme is helping for the digestion of fats into fatty acids and glycerols. Okay. Then what about protein breaking down into amino acids? The protein breakdown takes place in both stomach and intestine, in small intestine. Okay. Then the next question, in anaerobic process, it is take place in yeast during fermentation, take place in the presence of oxygen, produces only energy in muscles of human beings, produces ethanol, oxygen and energy. What is the correct answer? In anaerobic process. Okay, anaerobic process. What do you mean by anaerobic? Anaerobic means without oxygen. Without oxygen. The anaerobic process. The correct answer is it is take place in yeast during fermentation. It is take place in the presence of oxygen. No, that is aerobic process. That is aerobic process. Produces only energy in the muscles of human beings. No, that is not correct. They also produce lactic acids. The accumulation of lactic acids in muscle cells that leads to muscle cramp. The option C is also wrong. What about fourth one? It produces ethanol, oxygen and energy. It is right? No. It produces ethanol, carbon dioxide and energy. Then is an important area, that is what are the difference between aerobic respiration and anaerobic respiration. It's very important. The aerobic respiration take place in presence of air or oxygen. Okay, what about anaerobic respiration? It take place in absence of oxygen. The anaerobic respiration is take place in absence of oxygen. Then aerobic respiration, which occur in two steps. The first one is glycolysis. It is take place in the cytoplasm of the cell. Then the second one, there are several sequence of reactions there that is take place in the mitochondria and finally produce large amount of energy. Okay, in anaerobic process, it is only take place in cytoplasm only. What about aerobic respiration? The cytoplasm and mitochondria. Okay, you can split the third point into two. The aerobic respiration, the complete oxidation of glucose is take place. The complete oxidation of glucose is take place. What about anaerobic respiration? It is a partial or incomplete oxidation. Partial or incomplete oxidation of glucose. The end product of aerobic respiration. What are the end product of aerobic respiration? The end product of aerobic respirations are, that is CO2 and water. What is the
What about anaerobic respiration? It is ethanol or CO2. You can write ethanol is an alcohol. That's why alcohol with the CO2. Here in aerobic respiration, large amount of energy is forming. In aerobic respiration, large amount of energy is formed. What about anaerobic respiration? There is very less amount of energy is formed. And the examples of aerobic respiration. What are? It is formed in plants and higher plants. Anaerobic respiration seen yeast and lactobacillus. Is it clear? Is it clear? Okay, then we will move into the next question, that is sixth question. Why is there is a difference in the rate of breathing between aquatic organism and terrestrial organism? What is the difference between the rate of breathing? Okay, what is the difference between the rate of breathing in aquatic organism and terrestrial organism? You remember the point. In water, the amount of dissolved oxygen is the amount of dissolved oxygen. Dissolved is less as compared to the amount of dissolved oxygen in air or atmosphere. Okay. Why there is a difference in the rate of breathing in aquatic organism and terrestrial organism? In water, the amount of dissolved oxygen is less as compared to the amount of dissolved oxygen in the air or atmosphere. That's why the terrestrial organism increase their rate of breathing. Okay, speed up their breathing rate. Okay, is it clear? Is it clear? You can get a 2-mark question. So 2-mark question. Then we will move into the next question. Seventh question. It's very important question. Describe the blood circulation in human beings. Describe the blood circulation in human beings. Look here. We are starting from the body parts. After the cellular respiration, okay, what are the end product of aerobic respiration in animals and higher plants? That is carbon dioxide there, water there, and energy there. Energy there. Okay, this CO2 that is present in various parts of our body. Okay, in our body, every part has cells and tissues, and these cells and tissues have CO2 as a waste material. This CO2 is diffused into the blood. In the various parts of the body, the CO2 is diffused into the blood. And what will happen there? The CO2 from various parts that is entering into the right atria. This is right atrium. That is right atrium. Yes, right atrium. The deoxygenated blood. When the CO2 is present in the blood is called a deoxygenated blood, which is represented by these blue colors. Okay, the deoxygenated blood is reaching the right atrium through superior and inferior vena cava. From the superior vena cava, superior means above the part, okay, above the top part of our body, it will reach above the body, it will get the blood and it is finally reaching our right atrium. So inferior vena cava, which collect the blood from lower part of our body. Okay, then it is reaching the right atrium. Okay, it is reaching the right atrium. When the right atrium becomes filled, the walls of right atrium become contract. The walls of right atrium become contract. Then what will happen? The blood is flow into the right ventricle. The blood is flow into the right ventricle. When the blood is reaches the right ventricle, the right ventricle becomes filled with a deoxygenated blood, because we are collecting the blood from various body parts. Then the CO2 is dissolved in this blood. Then the blood is called a deoxygenated blood. The deoxygenated blood is reaching the right atrium. Then it is moved into the right ventricle. From the right ventricle, the blood is filled. Then the right ventricle, the walls of right ventricle become contract. Then what will happen? When the walls of right ventricle become contract, it will reaches, the blood is reaches the lungs through pulmonary artery. Through pulmonary artery. The only artery that carrying deoxygenated blood is pulmonary artery. Okay, remaining arteries are carrying oxygenated blood. The only artery that carrying deoxygenated blood are pulmonary artery. Is it clear? Is it clear? From the pulmonary artery, it reaches the lungs. Then the diffusion takes place. Okay, the CO2 is released in the lungs. Okay, the oxygen from the lungs is entering into here. Look here. The oxygen from the lungs is entering into pulmonary vein. Then the blood in the pulmonary vein is oxygenated blood. Okay, the blood in the pulmonary vein is oxygenated blood. This oxygenated blood is reaching the left atria. Okay, it is reaching the left atria. The only vein that carrying oxygenated blood. The only vein that carrying oxygenated blood is pulmonary vein. Okay, remaining veins are carrying deoxygenated blood. Is it clear? Is it clear? Then the pulmonary vein that is reaches the left atria. The left atria contain oxygenated blood. The left atrium contain oxygenated blood. From the left atria, it will reaches the left ventricle. Okay, the oxygenated blood is reaching the left ventricle. From the left ventricle, through aorta, it reaches various body part. Through aorta, it reaching various body part and supply the oxygen into various body organs. Is it clear? Is it clear? Fatima, is it clear? So Yusuf Abdul Latif is there. Shamil is there. Is it clear? Then we move into the next question. The 8th question. What two water conducting tissues present in plants? How does water enter continuously into the root of xylem? First question was, write the two water conducting tissues. What are the two water conducting tissues present in plants? That are xylem vessels and xylem tracheids. Xylem vessels and xylem tracheids are two water transporting tissues found in plants. Is it clear? Then how does water enter continuously into the root xylem? If you are considering a tree, these are the roots. Okay. Here, look here. The root cells are there. The root contain root cells. The root cells actively absorb minerals from soil. Okay, the root cells actively absorb. What do you mean by active absorption? By the cells provide some energy in the form of ATP for the absorption of ions. okay, which will collect some ions from the soil. Okay, if it collects from ions from the soil, the osmosis take place. Okay, what is the definition for osmosis? The movement of water molecules from higher concentration to lower concentration through a semi-permeable membrane. And this process is called osmosis. Here, the ions are entering into the root through activity. Here, the concentration of ions increases. The concentration of ions increases. When the concentration of ions increases inside the root cell, what will happen? The concentration of water molecule will be decreases. Okay, as compared to soil, the water molecule concentration is very less. Here in soil, the concentration of water molecule is very high. Then, according to osmosis, water is moving from higher concentration to lower concentration through a semi-permeable membrane. Okay, here water is moving from soil to root. And this theory or this phenomena is called root pressure. Okay, it's creating a root pressure and its water moving to upward. But it is not possible in case of higher plants. Okay, in case of higher plants, this pressure is not enough. That time, this is another phenomena is called a transpiration pull. Okay, transpiration pull. Okay, what do you mean by transpiration? The loss of water molecules in the form of water vapor from the aerial part of the plant, especially the stomata. Okay, especially the stomata. Okay, here the water molecule is evaporated. Okay, to compensate the loss, the stomata take water from neighboring xylem cells. Okay, neighboring xylem tracheids and xylem vessels. Okay, here this cell lose water. Then this cell collect the water from this neighboring cell. Then this chain of processes take place and finally reaching the root, and it's a pull. Okay, the water is pulling. Okay, here is a water loss. Here is a pulling is take place. This theory is called a transpiration pull. Okay, these are the two methods for transport of water and minerals in plants. Then the second question. Explain why plants have low energy needed as compared to animals. Why plants have low energy? Because most of the cells in plants are dead and plants does not have any locomotion. Okay, plants does not have any locomotion as compared to an animal, and the most of the cells in plants are dead. That's why plants have or plants need very low amount of energy for their life process. Is it clear? Is it clear? Then the next question, what is transpiration? Lists its two functions. Okay, I already talked about transpiration. Transpiration is the loss of water molecule. It's a loss of water molecule in the form of vapor. Okay, in the form of vapor in the aerial part of the plants, especially mainly the stomata. Okay, water is evaporated through stomata. Okay, then list its two functions. I already discussed one function, that is transpiration pull. It is helping for, the transpiration was helping for the absorption, transport of water and minerals from various part of the plant, from the root to various part of the plant, and it also provide a cooling effect. Okay, that's why it is important role in thermal regulation. When the water are evaporated through the stomata, okay, waters are evaporated through the stomata, what will happen? There is a cooling effect is provided. This cooling effect is important for the thermal regulations around the plants. Is it clear? Then the last question, draw a neat diagram of human excretory system and label the following part. One is urethra, kidney, urethra and urinary bladder. Okay, if we are drawing a kidney, the left kidney must be at higher position. Okay, it is not in the same way or in same plane. The left one is upper and the left one is upper and the right one is little bit lower. Okay, then this is kidney. This is kidney. Then this is urethra. Okay, urethra. A pair of urethra and a pair of kidneys are present in humans, and a urinary bladder which store the urine. The urinary bladder which store the urine. An external opening that is called a urethra. What is called urethra? Okay, very important. Then the final question: what are the nephrons? Nephrons are the structural and functional unit of kidney. Okay, that are the structural and functional unit of kidney. If you are drawing a nephron, it has each end of the nephron as a cup-like structure that is called a Bowman's capsule. That is called Bowman's capsule. Inside the Bowman's capsule, there is a network of blood capillaries that is called a glomerulus. Okay, then here there is a convoluted tubules there. Then these are convoluted tubules. Then Henle's loop is there. And finally, it is attached to the collecting duct. Finally, it is attached to the collecting duct. Okay, these are Bowman's capsules. Then here the filtration process takes place through the convoluted tubules and Henle's loop. Reabsorption of materials take place, especially glucose, amino acids, sodium. These elements are reabsorbed. Mainly the water also reabsorbed in this area. Okay, here it is helping for their filtration process. Okay, you get the idea? Is it clear? Okay, for details of further lives and more notes, okay, you can follow our WhatsApp community. Thank you guys for watching.